So on this slide, we want to go ahead and derive the the measurements of the side lengths of a 30, 60, 90 triangle. So our goal here is that we're going to want to find the height of the segment D to B, which is going to be that altitude line drawn right through the middle of my equilateral triangle. And of course, we want to write our solutions in the simplest radical form. So let's go ahead and look at this first triangle. So again, remember that I want to be able to solve for the three sides of this triangle right here. So let me go ahead and highlight the triangle. So this triangle right here. So I want to go ahead and find all of the angle measurements first. Remember, this is an equilateral triangle. So all of the angles in an equilateral triangle are going to be 60 degrees. Right? All the angles in an equilateral triangle are going to be 60. So we only care about the triangle in the blue, right? So I want to go ahead and I want to take the angle up here at B, and I want to go ahead and get rid of it, or not get rid of it, but I need to split it in half because I only want half of it. So that means that I need I want just this little piece, which is going to be half of 60, which will then give me 30. And now we have our 30, 60, 90 triangle. So now let's go ahead and find all of the side lengths to that triangle. So let's go ahead and let's rewrite. Let me just go over this again. That's going to be that. This will be B. This will be C. All right, so let's go ahead and take this triangle, and we're going to copy it and move it off to the side. That way we can work with it individually. All right, so now this is what I want to do. I want to find all the side lengths. So first thing we should notice is that all the side lengths of my equilateral triangle are going to be 1, correct? So if I'm looking for just this side right here in the blue, then this side has got to be half of the whole side over here. So this has got to be 1/2 of 1, so which is 1/2. So now the only thing I need to do is I need to solve for x right here. So now I need to solve for x. So let's go ahead and move this off to the, let's scoot this down a little bit, and let's use the Pythagorean theorem to solve for x. So I've got 1/2 squared plus x squared equals my hypotenuse squared. So this is going to give me 1/4. 1 squared is just 1. Let's go ahead and subtract 1/4 from each side. So then I get x squared equals 1 minus 1/4 is 3/4. I'm going to go ahead and square root each side. So square rooting 3/4 is the same thing as square rooting 3 divided by the square root of 4. So we're going to go ahead and simplify that by rewriting it as the square root of 3/2. So now we solved for x. X is now equal to the square root of 3/2. Now we're going to go ahead and solve all the side lengths to another triangle, and let's see if we can find a pattern. So now I'm looking at triangle, at the second triangle, but now my side length is 2. Remember, I'm only looking for the lengths of that triangle right there. We're going to go ahead and write in the angles. This is still 60 degrees because it's an equilateral. All the angles are 60. This is still 90, and this is half of 60, which has got to be 30. So there's my 30, 60 triangle. Let's go ahead and copy this down. So this is 2, this guy is B, this is C, and this is my D. So let's go ahead and copy this triangle again. That way we can work on it off to the side. There we go. Whoops. All right, let's try that again. Actually, I just need to paste it, don't I? All right, there we go. So same thing. Let's go ahead and find all the side lengths. So if I wanted to find this length right here, just like we did in the last one, we know that this entire side is 2. So that means this has to be half, right? This has to be 1 right here since these pieces are equal. So now I've got to solve for x right here. So let's go ahead and let's solve for x. So we're going to go ahead and use the Pythagorean theorem again. So x squared plus 1 squared is going to equal to 2 squared. Let's go ahead and solve this out. Let's subtract 1 on each side. Square root it, and now I get x is equal to the square root of 3. Alright, so now we're looking for patterns again, right? So what do we notice about both the answers to my triangles, right? This one, when we solved for x, we got radical 3 over 2. And when we solved for this one, we just got radical 3. So what would happen if I had a triangle with side lengths of, instead of having a side length of, I don't know, 1 or 2, what if I had a side length of 4? Then this would be half. I would end up doing the Pythagorean theorem to solve for this side, and I would end up getting, I already know the pattern, so you would end up getting 2 radical 3. Notice how every time on the height here, you always end up with radical 3, every time. So then where does the number in front of the radical 3 come from? Well, that number is going to come from this side, right here. Notice how that 2 just ends up right there. All right, and we can see another example here. We can see the 1/2 just ends up right there, right? Obviously the 1 is invisible, but there's a 1 there. It's 1 over 2, right? If I go to the other triangle here, we can see that this 1 is invisible, but it ends up right in front of it, 1 radical 3. So if I had to create a formula for this, then let's say this we would call, let's call the hypotenuse 2x, then this side would be half of 2x, which is just x, and that would make this x radical 3. And that's going to be our side lengths or formula for my 30, 60, 90 triangle. Okay guys, so here are the two formulas that we just went over. I just wanted to review them really quick because we did them kind of quickly. So the two triangles that we have are the 45, 45, 90 and the 30, 60, 90 triangle. So if we look at the 45, 45, 90 first, remember that this is going to have two of the exact same sides. This is going to have an A, and it's going to have another A right here. And the way I like to look at it is I always look at the angles, right? So 45 degrees, this one's going to go with side A. And since this one has the exact same angle, then it should go with the exact same variable opposite of it. And then we have our hypotenuse, right? The hypotenuse is always opposite of the 90-degree angle. So I know that the hypotenuse is always going to be whatever that side length is times radical 2. Now at 30, 60, 90, now with this one, all three sides are going to be different, so it's really important that you know where all three angles are. So the first one I always like to start with is the small side. So this is the small side right here. This is the side A, and it is always opposite of the 30-degree angle, right? This is going to help us out later when this triangles get rotated and reflected. It's going to help us to match up the sides a little bit easier. Then we've got the long side, the hypotenuse, right, 2A, which is always opposite of the 90-degree angle. Right, so that's going to point right there. And then we have the medium size length, which is going to be opposite of the 60-degree, right? So there's my 60, opposite of the 60-degree is my side length A radical 3. All right, so we're going to use that. We're going to correspond these side lengths to whatever problems we have, and we're going to use that to solve for missing variables. So let's look at some examples. So we want to look at some examples with the 45, 45, 90. So with these types of problems, you're always going to have two different cases. So as you guys are working on examples for your homework, any triangles involving 45, 45, 90 are going to simplify to one of these two cases. Let's look at the first case. The first case is when you were given the hypotenuse. No, I'm sorry. The first case is when you're given a leg of the right triangle and you're looking for the hypotenuse. So what I recommend you guys do is I recommend you guys have or keep your the formula of a 45, 45, 90 triangle close. You can rewrite it or you can just have it next to you, but I like to have it here, and what we're going to do is we're going to just match up the sides and we're going to set them equal to each other. So I'm going to go ahead and just match up all the sides here, right? We know that the 45, the sides opposite the 45s are going to be your A's, right? So the sides opposite your 45s are going to be your A's. Same thing on the other triangle. The sides opposite the 45, this is going to be your A. And if this is 45, if this side's 45 and this is 90, then in order for this to equal to 180, then this also has to be 45. So this is also 45, which makes this 8 as well. So we're going to go ahead and label, so we're going to go ahead and just label the sides that way. And I'm going to create an equation with these side lengths that I have drawn in red, right? I'm going to match those up. And then I'm going to go ahead and match up the other side lengths, right? Opposite the 90 is going to be your A radical 2, right? Opposite the 90 is going to be your X in this case. And I'm going to put the formula, or I'm sorry, I'm going to put the equation that I get with the sides in blue there. So let's see what this looks like. So I'm going to go ahead and match up the sides now. I'm going to go ahead and take the 25, so this side 25, and I'm going to go ahead and equal it to the side length measure on the other side, which in this case is A. So done. I already got a piece of information there, A. Now I'm going to go to the other triangle, and sorry, I'm going to go to the other side length in blue, X, and I'm going to equal that to A radical 2. So now I think, okay, man, this would be, I would already have my answer if I just knew what A was. Well, I do know what A was. I do know what A is. A is 25. So I'm going to go ahead and replace A with 25. And I'm all done with the first case. So that's how all of these problems are going to work. You're going to set up an equation, you're going to solve for A, and then you're going to plug it in to the other equation. So let's look at the second case. All right, so in that case, we're done, right? We found our hypotenuse. So X equals 25 radical 2. Now let's go to the second case where now we're given the hypotenuse, and now we have to find the leg. So again, let's have our 45, 45, 90 triangle drawn somewhere nearby. Let's go ahead and match up the sides. So this A side is going to go with this side. This side A right here is going to go with this side right here. And then I've got my, and we'll put the equation for that guy right here. And then I've got the hypotenuse here, A radical 2 is going to go with 88 right there. So we're going to go ahead and write down any formulas we see. So in the red, I see that X is going to go with A, right? They match up and correspond, right? X is going to go with A. And then I see that 88 is going to equal to A radical 2. So if I look at this,